Hello, I am Dr. Milind Koranne. Let me explain you working principle of a rotary dobby through an animation. Now what you see here is an animation of a rotary dobby. Rotary dobby is also called as an eccentric dobby. Now let me explain you the working principle of the rotary dobby. Now this rotary dobby has a main shaft. This shaft is given an intermittent rotation. That is, it does not rotate continuously, but it makes 180-degree rotation, then it stops for a while, again it makes 180-degree rotation and stops for a while. So if you take one peak duration, for part of the peak it completes its 180-degree rotation, and for part of the peak the shaft remains stationary. This unit what you see here is for one hill shaft. This shaft is common for all hill shafts. This main shaft carries number of such rings, each ring for one hill shaft. Each ring is made fast on the shaft, and each ring carries two keyways which are diametrically opposite to each other. So this is one keyway at 180-degree diametrically opposite. This is the other keyway. This ring carries an eccentric shown by green color in the animation. This eccentric is free on this ring, that is, there is a bearing between this eccentric and the key and the ring. Now when the main shaft rotates, this ring also rotates, but eccentric will not rotate because this eccentric is loose on this ring. So if the ring rotates, the eccentric does not rotate. That is what you can just see. Now this eccentric carries a key on it. This eccentric carries a sleeve shown by this purple color in the animation. Now this is just the working principle. Now this sleeve is connected through proper links and levers. It is connected to the hill shaft. This is just a simple arrangement that is shown. So this unit is connected to the hill shaft through suitable links and levers. This is just a basic representation that is shown. The actual on the machine is little different, but principle is the same. Now, as I told you earlier, if this eccentric rotates, then what will happen? That there will be change in the position of the hill shaft. If this eccentric does not rotate, the hill shaft position remains the same. Now let us see further. Now what you see here is that this key has engaged the keyway in the ring. So now the eccentric has become fast with the ring. So now when the ring will rotate, the eccentric also rotates from its one dead center to the other, and thereby what will happen is that the position of the hill shaft is changed from down to up. Thus, what you observe here is that when the key is engaged in the keyway, there is half rotation of the eccentric and there is change in the hill shaft position. So previously it was down, it will go up, and vice versa. Now let us see what happens for the next peak. Now for next peak, the key is taken out. Next peak, what happens? Even if the ring rotates, the eccentric does not rotate. So what has happened for the next peak? The hill shaft position remains the same. Now let us see what is the next hill shaft position. Now again next peak, the key is not engaged in the keyway. So even though this shaft has rotated, the hill shaft position remains the same. Thus, if the key is not engaged, the hill shaft retains the same position. Now let us see what happens for next peak. Now we have engaged the key. So the position of the hill shaft will change. So as you can see that previous peak it was up, now the hill shaft has come down. Thus, every peak, this ring rotates by half rotation. Now if you engage the key, there is change in position of hill shaft. If you disengage the key, the hill shaft position remains the same. So the selector mechanism of the Dobby has to manage the engagement and disengagement of the key in the keyway of the ring. If that can be done, then you can get the desired lifting order of the hill shaft. Now let us see what happens for next peak. The key is kept engaged, so hill shaft position again changes. Now for next peak, the key is disengaged, so hill shaft position remains the same. Again key is engaged, so hill shaft position changes, and so on. Thus, the working principle is simpler, and this Dobby is a positive Dobby. It does not need any reversing agent, and this Dobby is capable of running at high speed. Now let me show you. It's running in slow motion. So key is disengaged, hill shaft position remains the same. Key is engaged, hill shaft position changes. Key is disengaged, hill shaft position remains the same. Engaged, hill shaft position changes. Key is disengaged, hill shaft position remains the same. Key is engaged, hill shaft position changes. So this Dobby was basically developed in order to achieve very high speeds as well as have the positive shading. Hello, we have understood the principle of working of Rotary Dobby. Now let me show you a design used commercially on a Dobby. Now this is the main shaft. This is the ring that is already shown previously. The yellow colored thing is the eccentric. This is the sleeve, and this is the jack that is connected through suitable links and levers to the hill shaft. Now key is replaced by a catch here, you can just see here. This catch is fulcrum here and is spring loaded. So spring gives tendency to this catch always to engage in the keyway. So if I have to disengage, I have to apply the force here at this end in this direction so that this catch here will get disengaged. So for engaging the eccentric with the ring, this catch must move this way. And if I want to disengage this catch, then I have to push from here in this direction. To do that, this red colored, this indexing arm has been provided. So function of this is of selection. Now you will see this when I will run the animation. Now let me run the animation for you to understand. So please see the animation. It will give you some idea. So you must have observed here, let's say for example right now this catch has engaged the ring and the eccentric is rotating. Now if this arm, so I was talking about this arm, so if this arm is made to move in this direction, then it will touch this part of the catch and it will force the catch to disengage. So now let us see it. Now the catch is engaged, eccentric is rotating from one dead center to the other. Now this arm, it has come in the way of the catch and the catch is disengaged. So for next pick, the heel shaft position remains the same. So no change in the position of the heel shaft. So for next pick also, the catch is not engaged. Now this arm has moved this way, so now this catch will tend to engage in the keyway. So the catch engages and the eccentric rotates. Now again, catch is engaged, so eccentric is rotating, catch is disengaged, so no change in the position of the heel shaft. Again catch is disengaged for the next pick, so same position of heel shaft. Now catch is engaged, so there is a rotation of eccentric. Therefore, the selector mechanism has to manage the movement of this arm. So if this arm moves this way, then it will cause this catch to disengage when it comes over here. Now if this arm is made to move this way, then it will not come in the path of the catch. So if catch is here, it will tend to engage and eccentric will rotate. So this arm has to be given motion through the selector mechanism to decide the lifting and lowering of the hill shaft. Thank you. Hello. We have discussed principle of rotary dobby and also one unit. Now let me explain you modulator of a rotary dobby. Now what is modulator? I have discussed earlier that in rotary dobby the main shaft of the dobby should be given intermittent rotation. That is, it should rotate by 180 degree, then stop, again 180 degree, stop. So in a rotary dobby you need a unit that converts the continuous rotation received from loom drive into an intermittent rotation. So this is the animation that shows the working principle of a modulator of a rotary dobby. Now let me run this for your understanding. So what are the motions you observe here? You observe that here there is a gear of orange color and it is rotating intermittently. So that is, it is rotating by 180 degree and stop. That is what you can see with this reference arrow. Okay. There is a sector with yellow color that is rotating around the sun and is also rotating on its own axis. Now let me explain you the construction. This is the main shaft of the rotary dobby. This is a sun gear which is fast on the main shaft. Now this sun gear meshes with a sector which is mounted on an arm shown by this green color. Let me hide this sun gear so that you will be able to see it more clearly. So this arm carries the sector. Now this sector which is mounted on the arm receives the continuous rotation this way around this center. So this arm is given continuous non-stop rotation around this shaft. Now this arm is loosely mounted on this main shaft. So this sun gear is fast on the main shaft, but arm is loose on the main shaft. Arm receives continuous rotation from the loom drive. Let me show you that without the sun. So what you observe here is that arm has non-stop rotation around the main shaft. Okay. Now if arm is rotating continuously and if this sector is fixed, that is, it cannot rotate on its own axis, then you will appreciate that when this arm rotates this way, as there is no rotation of the sector allowed on its own axis, this teeth remains engaged here and the rotation of arm and the sun will be same. That is, if this arm will rotate by half rotation, the sun will also rotate by half rotation. So rotational speed of arm and sun will be equal. Now imagine if I don't rotate arm, but if I rotate this sector on its own axis, what will happen? So if sector will rotate anti-clockwise, arm will rotate clockwise and vice versa. So I can bring about rotation of sun by rotation of arm or by rotation of sector on its own axis. Now what will happen if both is done simultaneously? Now let me show you through animation. Now have a look here. Now see, arm is rotating. So arm has rotated from here to here. But at the same time, this sector is rotated in anti-clockwise direction. So arm is rotating anti-clockwise. Sector is also simultaneously rotating in anti-clockwise direction. So arm anti-clockwise direction rotation will tend to rotate this sun in anti-clockwise direction. But I am simultaneously rotating this sector also in anti-clockwise direction. That is tending to rotate this sun in clockwise direction. So one tries to rotate anti-clockwise, other tries to rotate clockwise. Now if both these movements are equal and opposite, then the resultant motion given to the sun is 0. And thus the sun will remain stationary. So what you have observed, again let me show you that from here to here there is no movement given to the sun. Again you try to see it. I will. Okay. So from here to here there is no motion given to the sun. Now in the later part, if I will rotate this sector in clockwise direction, so arm rotates in anti-clockwise direction. Simultaneously now if I rotate this sector in clockwise direction, what will happen? Sector will try to rotate the sun in anti-clockwise direction. So arm also tend to rotate it in anti-clockwise direction. Sector also tries to rotate it in anti-clockwise direction. So the two moments are added here and the sun gets the rotation, as you can see now. Now see, sun has also started rotating. Arm is rotating anti-clockwise, sector is rotating clockwise. So what you have noticed here, that from here to here no movement, and from here to here 180-degree motion of the sun. So this is how in this 180-degree, now 180-degree movement here is 360-degree of loom. So if this sector will move in anti-clockwise direction for 120 degree, then for 120 degree this sun will remain stationary. I am talking of 120 degree of loom. Here it will be only 60 degree. So for 60 degree motion here in the modulator, the sun remains stationary, and for 120 degree of movement of the in the modulator, that is 240 degree of loom, the sun rotates by 180 degree. So this is, so the arm has non-stop rotation in anti-clockwise direction and sector rotates in anti-clockwise direction in this area zone, and clockwise direction in this zone. So what happens to the sun? No movement here and 180-degree movement here. So again for next peak, no movement and 180-degree movement. So now I will reduce the animation speed and you try to observe it. So see 180-degree motion, stationary, again 180-degree motion, stationary, again 180-degree motion, stationary, 180-degree motion, or movement subtracted, movement added. Next peak, movement subtracted, movement added, movement subtracted, movement added, movement subtracted, movement added. So this is how the modulator of the rotary Dobby works. So I have tried to explain the working principle of a modulator. Now this sector, actually you don't have one sector, the arm extends here, there are two sectors and this sector carries two followers and there are two matched cams which are stationary. That is not shown in the animation. That can be understood through a diagram which is not included now. I will show you later on.